This time on Engine Masters, we are gonna blow your mind adding big power with nothing but a dipstick. Your oil is killing horsepower, I'll bet you a beer. Seriously. And I'm not even talking about like brands of oil or synthetic versus regular. Nope, it is all about oil control inside your crankcase. And this is going to apply to virtually any engine. What we're going to do to pick up significant power is dumbfounding. Honestly, you're not even going to believe it. And once we're through with that, you're also gonna see a comparison of a stock type oil pan like this versus a performance aftermarket pan. It's gonna be pretty good. Let's talk a little bit about what we're gonna use as a test mule here. If you've watched Engine Masters for a while, then you saw this in the episode that was called 600 horsepower camshaft shootout. We compared a hydraulic roller cam to a solid. Well, it's exactly the same configuration. This is a big block Chevy, it's a 454, it makes 600 plus horsepower, it's a pump gas deal, it's actually really, really cool. But the good thing about it is that it's got a giant rotating assembly down there because it's a big block, it's got a 4-inch stroke, it's churning all sorts of trash through the oil all of the time, and that's gonna be a big deal. And it also runs to 6,500 RPM because of the nice little solid roller camshaft in it. So it's a good candidate to show you how controlling the oil in the crankcase is going to make power. First thing that we're going to do is install this turd, fill it up with AMSOIL, of course, and then we're gonna run it and show you how you can make power with oil for less than free. And then we're gonna move on and spend a couple bucks and bolt on an aftermarket pan. Let's get to it. This should be pretty straightforward. I mean, stock oil pan, stock recommended level. What do you want to do as far as procedure to make sure we're consistent?
I think as far as the stock pan, we just want to verify that, make sure that it's repeatable temperature-wise, and then take a look at the curve and see if there's anything we think we can do to adjust it and make it as good as it can be.
Simple enough, make power. We've already got this thing all tuned up, ready to go. Off camera, we've run this thing like over and over, making sure that our routine is right and that it repeats exactly so that we can get an accurate test. We think this will be our last run, and then we'll be able to give you the baseline results. So our final answer is 577 pound-feet of torque at 4,100 RPM, and up top it made 614.6 horsepower at 6,400. But let's have a look at what's going on with the oil pressure, because we all suspect this is a little over full, and I'm gonna say yes.
And I checked that this is exactly what the factory recommends for this level with this filter. And actually, I thought it was kind of interesting, but if you use a short filter, it actually takes 6.7 quarts with a short filter and 7 quarts with a long one.
So they're down to that kind of accuracy.
Yeah,
That's interesting.
I thought it was great.
They're also not running 6,500 RPM from the factory. They're probably only running 5,000 RPM or less.
Yeah, with that fan originally on a 1-ton truck.
So you've seen this, right, Dulcich?
Well, the thing is, that suggests a control problem, but this particular motor has a solid roller, which is not going to be affected as much as a hydraulic flat tappet or hydraulic roller.
That's a good point.
There's no piston in there to lose compression and cost you lift and duration with the solid roller.
So let me tell you exactly what's going on with this curve right here. What we're seeing is that at high RPM above 5,000, the oil pressure is dropping off. And that means that there's probably too much oil in the pan, it's getting all whipped up, and Steve's talking about how that can affect a hydraulic roller camshaft. If there's a bunch of air in the oil, it's aerated from being whipped around, then that's why the pressure drops off, and if the pressure drops off, a hydraulic lifter is gonna start to fall apart.
Lose some squish.
So we're gonna go pull a quart out of this thing-ish, and hope we can see that improve. Here we go, run it. That's pretty happy for just draining a quart of oil out. We actually made more power. Let's have a look. So let's overlay the full oil pan versus the 1 quart low. Okay, there you go. Kind of predictable on the RPM, I think. You know, down below 5,000, it really doesn't matter. But once the crank starts whipping that oil around, what'd we see there, like 5 horsepower at peak? It's the difference between 613.8 to 619.8.
Oh, yeah.
6 horsepower just from draining a quart of oil out of the stock pan.
I have seen as much as 20 when they're a quart and a half or something too full.
In this case, I think for a street strip car, a drag racer, if they have any kind of data logging, can look at oil pressure and see the trends that we're seeing where it drops off at high RPM, they're gonna be able to apply this and figure out what they're doing and still be safe. So let's look at our final number with 1 quart out of the pan. So basically what we saw there is that it didn't affect the torque very much because the RPM is too low for that oil to really make a difference. But up top, the final answer with a quart low is 619.8 horsepower at 6,300 RPMs.
I'd like to take one quick look at the oil pressure.
Oh, interesting. Down and back up.
Now let's take a look at the other one and watch where it diverges. I'll bet it's right about 5,100 when the power starts to change.
Yep.
Oh, yeah.
So what we're looking at now is the difference in oil pressure between a full pan here, and by full I mean factory recommended, and up here with 1 quart low. It's actually, I mean, the scale that you're looking at between here and here is
2 pounds.
2 pounds, but up here, look at the difference. That's huge. So it's not just a power consideration, it's really a longevity consideration because you do this too many times,
It's got air in it.
Now we have to go find out if we can do a little bit better than that with the Mylodon pan. Now it's time to get into some speed parts with the racy Mylodon oil pan. But before I describe what's going on here, you gotta understand the concept of windage. And as that relates to an engine, it involves the crankshaft spinning around in the crankcase and all of the pistons and rods going up and down. And as they're doing that, they carry a fog of oil with them because the oil is coming out between the cheek of the connecting rod and the crank. It's dropping down from the lifter valley and off of the camshaft. And as it hits that crank and it's spinning around, it can carry what they say is up to a quart of oil in that spinning assembly. It's like a big fog. And that takes power because it's more weight that the crankshaft has to move and because all of the counterweights are hitting the oil in the air as it goes by. And it's just a power suck. And that's what we're gonna try and address with the aftermarket pan. So this oil pan is just like what you'd find on a stock Chevy truck. Let's say like a 98 3/4 ton with a 7.4 liter, a 454. And it's very basic, but it does have the advantage of this baffle in here. In the muscle car era, they didn't do anything like this and it was really bad. But what the baffle's doing is not so much controlling windage, but it's keeping the oil from sloshing around in here. Deceleration, all the oil goes to the front. You know, when you're cornering, it's just keeping the oil there in the sump so that you don't lose oil pressure. But we're hoping that this thing also causes a bunch of windage and that we're gonna find out that this aftermarket pan is gonna help that. So now we're gonna move on to the aftermarket oil pan and let's talk about what it does to solve windage. First of all, in addition to having sort of a baffle back here around the pickup, it has what's called a windage tray. Now, what that's designed for is if you look, this being the front of the engine and the crankshaft is spinning this way, it has a couple of things which are gonna help that fog of oil get removed from the crank. First, these louvers right here, you can see that they go the direction that that oil is being thrown to try and catch it and return it into the sump rather than let it fog around that crankshaft. Probably more importantly is this kick out on this side of the pan that matches up with a groove in here. And what that's designed for is for that oil to hit it and once again be forced to return into the sump instead of being carried around on the crankshaft. The other thing that you'll see in aftermarket pans is that they often have higher volume, higher capacity. There's 2 reasons for that. One, they think that more oil is going to just be better for lubrication in the engine. You've got more reserve in there. Second of all, pressure and volume are inversely proportional, and there's pressure in the crankcase as the engine is running. So if you have greater volume in the oil pan, it reduces that pressure and helps with like ring sealing and stuff like that. But most of those pans you'll see, they have a full length sump on them, whereas this is just a rear sump. For this test, I wanted it to be really valid for anybody with a passenger car or truck. That's why we're using a pan that just has a sump in the back instead of one of those full race pans, and those can offer even more performance. Before we go install this now, I have one last tip, and that is about oil volume. First of all, if you have a stock pan, you can go to the AMSOIL website and look up exactly how much oil it takes, and we found that that's really accurate. But if you have an aftermarket pan, I would say don't trust what the manufacturer says about the quantity of oil that goes in these things. Instead, what you want to do when you get a new aftermarket pan is get a bunch of empty oil jugs, fill them with water up to the full quart mark, and pour them into your pan just to the point where the oil stays underneath this tray, maybe even a little bit lower than that, because if the oil's up on top of the tray, you're just going to aggravate that windage problem. And so we often find that the capacity of these pans is a little bit less than what they advertise. And so what you want to do again is fill that with water and check it, and then fill your filter with oil, and that will tell you the total volume of your oil system for optimum performance. But you also always want to keep an eye on that oil pressure gauge to make sure that you are not losing oil pressure from windage at the top of your RPM range. Okay, so that's enough theory. Now we're going to get into the fact as we install the Mylodon pan on our big block Chevy.
There we go.
I don't have any nuts over here, do you? So the oil pan swap is pretty easy. We'll button this thing up and then go find out if it makes power. Okay, next up we're gonna show you what happens when you think that you're extra safe by running even more oil. That Mylodon pan is designed for 6.5 quarts, and we're gonna run it with 8.
That's a lot of oil for sure.
That's gotta be above the level of the windage tray. It's too much. So we've got the engine up to temperature off camera. We did a couple pulls. We've now got oil temperature sensor, which is very cool. And we followed our routine of what we were doing before. We're gonna do the same thing now so we can get a really clear A/B test of the old pan versus the Mylodon pan with the 8 quarts in it. All right, we're ready to go. So that killed power. So that was pretty much what we expected. We thought we were gonna see the power drop just because of too much oil, and I think we did. I noticed the oil pressure was lower throughout the curve than it was before, and I think that's because there's just so much air in it.
I think you might be right. I think we might not be seeing the big swing and fluctuation because it's always got windage with this much oil.
Before we look at the power, let's look at the oil pressure curve. Yeah.
Ooh.
Yeah, see, it only peaked at 74, and look at that big drop, but why does it come back up?
I think it's because it's pumping enough to
Right.
the top that now it doesn't have a whole bunch in the pan to make
Right.
windage. So
Yeah, so if it's that much too high, then at RPM it's sucking it up and putting it up in the valve covers just enough to get it out of the way. That's probably what's going on. So now let's look at how much power that killed. Oh! So super interesting. Basically, we just ran the aftermarket pan with what we believe is way too much oil in it, and look at the curves. The red line represents the stock pan with the reduced oil level in it, and the black line shows that we killed 22 horsepower with too much oil in the aftermarket pans. I bet the audience has no idea that too much oil kills 20 horsepower.
it's surprised a lot of people over the last 10 years or so when we started doing these tests.
So the question really is, how much oil do we drain out of it?
I think we do it a quart at a time.
Okay, I think we're gonna take 3 quarts out of it. I think this thing wants 5 in the pan and 1 in the filter. We picked up some power, but we're still losing oil pressure. Pull another quart out.
I agree.
Now we have 6 quarts in the pan. I'd still pull a quart out to see what happens.
We have to.
Yeah. All right, now we're down to 5, which is the number I called.
I think you might be right,
That's
actually.
the most important part of the episode.
I know.
Is me being right. test run yet.
Thank you. You win.
Thank you. Thank you.
Nice work, Freiberger.
All right, let's see what happened.
Can I revise my guess to say 4 quarts? I bet it makes one more.
Hey, the way it's trending, how about no oil? It seems like that would be best, right? Okay, what's the comparison you're gonna call up? 6 versus
against
5?
The 6 quarts, yeah.
There you go. 6 quarts versus 5 quarts. We're starting to get to the point of diminishing return. But as you can see, that lower oil level made more power. Our new peak, 627.9 horsepower, which is the best run we've ever made.
That's really good.
Yeah.
Pick up another 7 or 8. I mean, that's...
Yep. Let's look at the oil pressure and see what we think about that. I'll take a look at that. This oil pressure curve right here that's low is with 6 quarts in the pan, and this is with 5 quarts in the pan. This is sort of an anomaly here that is the difference between 75 and 71. So it's 4 PSI, but it's trending the right direction up at RPM. So I think we're there, right?
Yeah, I think we are. I find it interesting that with the exact same oil temperature,
right,
200 degrees, the oil pressure is still higher there by 2 or 3 PSI, even starting out. Yeah, but even at low speed. I mean, I would expect that to be better at higher speeds like it is.
But the air
low speed
stays in the oil. You can see those little bubbles hanging out in there for 5 or 10 minutes, right?
That's a good point, because after I was done warming it up and making a couple runs to get the temperatures right, there was still air left over.
Right.
Good call.
Wow, that's pretty good. Let's look at our final power numbers of the optimum oil in the Mylodon pan versus the optimum oil in the stock pan. And there you go. There's the gain that we saw from the aftermarket pan right up here at the top. Again, the benefits are all at the higher RPM range, but the crank scraper, the windage tray, which, let's be honest, are really basic in this thing, not really optimized, just bolt-on parts, and it gained us, what? 8 horsepower.
8.5.
Yeah, all the way up through here, but the real indicator there is that the oil is happier and everything.
Engine's probably going to live longer.
It's all wind.
Just with real oil in it instead of oil and air.
Yep. All right, so that was great, but I actually think there's a little more to talk about.
Well, like what?
Oh, I'll tell you.
Okay.
A few more tips and tricks.
I'm all ears.
Remember when you were a teenager and you wanted to adjust your ignition timing, and so you would go out and floor it and keep advancing it till it pinged and then back it off 1 degree?
How else would you do it?
You know what I just learned from this episode?
What?
You'd want to just keep draining oil out of the thing until the engine blows up and then add a quart.
Oh man, I wouldn't do it that way.
I know. I'm actually, the reason I say that is I'm a little worried that a lot of people will take that away from this episode and go, oh man, just keep draining oil out, it keeps making more power. That's not really the deal. What we sought out was the right oil level on the dyno. It's probably gonna be a little bit more if you're driving around in a car and you've got to deal with like acceleration and all the oil going to the back of the pan, deceleration with it all going forward, going side to side and cornering. All of that can uncover the pickup and give you oil pressure problems. So you always have to look at that instead of just randomly draining the oil out. But nonetheless, the lesson of most oil pans telling you to run way too much oil, I think, is a big one. The other point that I wanted to make is people should be aware that the oiling problems are going to be worse the longer your stroke and the higher your RPM. Those are the things that are really going to make that windage a big deal.
Yeah, because it's going to be more likely to grab oil and wrap it around that crankshaft.
Yep.
There's actually a lot more you can do to control the oil than what we showed here as well.
Oh yeah, we didn't even really try that hard. I mean, we just bolted on an out-of-the-box pan. There's a bunch more that we can do to control oil and make power.
You can add scrapers or additional baffling and even windage trays that fit up tighter to the crankshaft.
Yeah.
All those things will help make more power.
Or a full-length pan. I mean, basically anything you can do to get the oil pan away from the crankshaft is going to be a win up to the point where it's dragging on the ground.
What's the ultimate setup then?
The ultimate setup?
Yeah.
Oh man, is a dry sump.
Oh man, that's the ultimate because it sucks all that oil right out of there.
Dry sumps make power. We should try one day, and maybe we will, right here on Engine Masters, which is presented by AMSOIL.
This pump is hotter than this pistol.
Ouch! Son of a gun. Imagine that, a hot oil pump on a hot engine. No waiting around here.